Hello everyone, I, Shivang Manas, is going to present on the topic optical fiber. These are the topics that I will be covering in this presentation. So, what do you mean by optical fiber? They are used most often as a means to transmit light between the two ends of the fiber and find usage in fiber optic communications where they permit transmission over longer distance and at higher bandwidths data transfer rates than electrical cables. Structure of optical fiber. These are the three main components of which optical fiber is made up of. The first one is core. The light is carried from the transmitter to the receiver through a central tube of very narrow size constructed of optically transparent dielectric material. The core diameter can vary from about 5 micrometer to 100 micrometer. The second one is cladding. The reflecting index of the outer optical material around the core is lower than the cores. It helps to keep the light within the core throughout the phenomena of total internal reflection. The third and the last one is coating. Plastic coating that protects the fiber made of silicon rubber. The typically diameter of the fiber after coating is nearly around 250 micrometer to 300 micrometer. Okay, so how does optical fiber function? The optical fiber works on the phenomena of total internal reflection. Light travels down a fiber optic cable by bouncing off the walls of the cable repeatedly. Each light particle, that is, photon, bounces down the pipe with continued internal mirror-like reflection. The light beam travels down the core of the cable. The core is the middle part of the cable and the glass structure. The cladding is another layer of the glass wrapped around the core. Cladding helps to keep the light signal inside the core. A fiber optic relay system consists of the following components. Transmitter. It produces the light signals and encodes them to fit to transmit. Optical fiber. The medium for transmitting the light pulse, that is signal. Optical receiver. It receives the transmitted light pulse, that is signal, and decodes them to be fit to use. Optical regenerator, necessary for long distance data transmission. Types of optical fiber. There are various categories in which an optical fiber can be classified into. Based on reflective index, step index fibers, it consists of a core surrounded by the cladding which has a single uniform index of refraction. Graded index fibers. The refractive index of the optical fiber decreases as the radial distance from the fiber axis increases. Based on the materials, glass fiber, it consists of extremely fine glass fibers, plastic optical fibers. The polymethyl meth acrylate is used as a core material for the transmission of the light. Based on the mode of propagation of light, multi-mode fibers, these fibers are used for short distance transmission of signals. Single mode fibers, these fibers are used for long distance transmission of signals. Optical fiber communication system. Here is the flowchart of the optical fiber communication system. Information source. It provides an electrical signal to a transmitter comprising an electrical stage. Electrical transmitter. It drives an optical source to give modulation of the light wave carrier. Optical source. It provides the electrical optical conversion. It may be semiconductor laser or an LED. Optical cable. It serves as a transmission medium. Photodetector. A photodetector is a semiconductor device that converts an optical signal into an electrical signal. A photodetector is used in a fiber optic receiver to convert optical AV signals. Electrical receiver. It is used for electrical interfacing at the receiver of the optical link and to perform the signal processing electrically. Destination. It is the final point at which we receive the information in the form of electrical signal. What do you mean by attenuation? Attenuation is the reduction in power of the light signal as it is transmitted. It is caused by passive media components such as cables, splice, and connectors. Pros of optical fiber. Pros of optical fiber. Connection quality. Fiber optics are resistant to electromagnetic interference and have a lower rate of bit error. Electromagnetic interfaces (EMI) is a disturbance caused by electromagnetic radiations from an external source. This disturbance can interrupt or degrade the performance of a conventional metallic cable connection. Any object that carries electrical currents can create interference, such as the power lines or even the sun. Fiber optics are also resistant to corrosion. Scalability. Fiber optics are more scalable as it's simple to install. New equipment can over original fiber. Wavelengths can be turned on or off on demand, which allows for the easy provisioning of services and quick scaling for a growing business. Optical fiber are also much smaller and lighter than copper wiring. These fibers can typically be placed in preparation for growth need up to 15 to 20 years in the future. Alternatively, additional cables can be installed later to make way for network expansion. Security. Security is a major concern for today's business. Fiber optics do not radiate signals, so there is no way to listen in on the transmission passing through. Breaches are also easy to identify as soon as they occur, as any physical break in the system will cause a total system failure. Instead of hardware in several locations, fiber optic networks allow you to keep hardware in one location. This makes regulation and maintenance much simpler. Long-term cost effectiveness. Long-term fiber optic network do not require the same overhead as copper networks. Fiber optic networks are more expensive upfront. However, the capacity for scalability long-term outweighs the initial investment. As the popularity of fiber optics grows, we are likely to see a decrease in cost over time. Challenges of using optical fiber. Physical damage. Fiber is thinner and lighter than metallic wiring, so it makes for a more delicate system. Because fiber optics are small, they can be easily cut by accident during building renovations or rewiring. As fiber optic cable can transmit much more data than metallic network, fewer cable service a greater number of people. This means that cutting just one cable could disrupt service for a large number of business and individuals. Short-term cost effectiveness. Although costs are lower over the long term, fiber installation cost can still cost a pretty penny to implement. Special test equipment is often required along with installer then have skilled knowledge about lying a fiber optic network. Fiber endpoints and connection next uses also require special equipment and setup. In addition, it may take specialized equipment to diagnose an issue with the fiber optics network, making for higher cost fixes should the cable sustain damages. Fiber fuse. At higher power, fiber optic networks are also susceptible to something known in the industry as fiber fuse. This occurs when too much light meets with an imperfection in the fiber. This occurrence can destroy long lengths of cable in a short amount of time. Unidirectional light propagational. Fiber cables are also limited in the sense that they can only propagate light in one direction. If bidirectional communication is necessary part of information transmission within a network, two concurrent cables must be laid in order to achieve bidirectional propagation of information. Top optical fiber applications telecommunication field as voice telephones, video phones, telegraph service, message and data networks. LAN systems of offices, industries, plants, college, military applications such as aircraft, ships and tanks, and much more. Medical field as endoscope. The future of optical fiber. Fiber optic technology is expected to play a major part in the growth. A research and market study determined that the compound annual growth rate for the fiber optic market could reach 8.5% by 2025, meaning more industries will be looking to the solutions presented by the technology from healthcare system to the marine environment. Fiber optic cable is proving to be a crucial component of industrial infrastructure. The expansion of new 5G wireless technology is being made possible with the help of fiber optic cable. Weird magazine report that telecom leaders are relying on millions of miles of new cables allowing 5G devices across the globe to better connect and network with one another. With the price of smartphones decreasing in developing countries such as China, India, and Brazil, this connection has never been more important for so many. The internet has transformed technology in many nations around the world, but some remain relatively untouched by its power. However, this is about to change for good thanks to a new Facebook initiative called Simba, an underwater data cable that would encircle the entire continent of Africa. This cable will ideally offer access to new markets of users while also minimizing bandwidth costs. Fiber optic technology continues to develop alongside the increased demand for greater speed and efficiency. New devices such as optical couplers and optical switches are supporting a recent trend known as all optical network or ON AON. This new technology allows data to be transmitted quickly without any electrical processing, which will result in the further transmission distances. Thank you. Thank you so much.